Welcome back to Chapter 3, video number 5. This video discusses measures of position. I'm Mrs. White. I'll be your guide. Alright, the goals for this video are listed here. We have 5 things to do. Calculate z-score, calculate percentiles, both ways, both how to find a percentile of a data point and then how to find what data point is in a specific percentile. Deciles and quartiles, just an application of percentiles, and then look at the symbolic notation for all of these things. So these are your learning objectives for this video. Okay, now it's time for me to explain what standard score is. Suppose you're in a class and you have teacher number 1. This is a teacher 1. Oh, look at this teacher. Teacher A. Oh, teacher A. Very happy teacher. And teacher B. Teacher B is kind of grumpy. Grumpy teacher. Right? And they both give an exam. And what we find is teachers A students had a mean of 80. And they're all kind of grouped pretty tightly around 80. So that's right there. And a standard deviation of 2. Well, this teacher had a mean of 75. And pretty big standard deviation, a standard deviation of 10. Pretty large for an exam. So, well, maybe not that large for an exam, but larger than 2 for certain. So the question is, your friend Joe there's Josephine, and your other friend Sally, there's Sally, both got 82s on the exam. Which friend actually did better relative to the performance of their class? Which one actually did better relative to the performance of their class? So is an 82 here better or worse than an 82 here? And we are going to figure that out. And the way that we do is we use something called standard scores. So we standardize the scores based on their mean and their standard deviation. And we ask this question with standard scores. Standard scores ask this question: how many standard deviations away from the mean is the data point? So this gives us an idea, the standard score gives us an idea how many standard deviations away from the mean is the data point, meaning how far away from the mean relative to the rest of the set did somebody do. So the formula is the value, whatever point you want to see, minus the mean divided by the standard deviation. So it's the difference between the value and the mean divided by the standard deviation. You'll notice this is also the formula for K in Chebyshev's rule, because K is the number of standard deviations away from the mean. These are the same thing. We use Z as the notation for this, and we often call this the Z-score. So that's the street name for standard score, is Z-score. If you have a sample, of course you use the sample notations, and if you have a population, of course you use the population notations. So that's how that works right there. So let's recall what we had for our example problem. Remember, we had 2 teachers, and we were comparing students with 82s. So our value was 82, a mean of 80, and a standard deviation of 2. And the other teacher, we had a value of 82, a mean of 75, and a standard deviation of 10. So summarizing the data, it looks like this. If I want to find the z-score of person number 1, of our student number 1 who got an 82 in the happy teachers class, then we go 82, that's our value, minus our mean, divided by the standard deviation. And this is 1 standard deviation away from the mean. Now if we look at this one, go 82 minus 75 divided by 10. This is only 7 over 10, or 0.7 standard deviations away from the mean. So actually, this girl over here did better. She's 1 full standard deviation above the mean, while this person, Sally, over here, was 0.7 standard deviations away from the mean, because this test varied a whole lot more. So this is a way to compare how they are relative to their set. This person, relative to the rest of the kids in her class, is a lot higher to the right than this person, relative to the rest of the students in her class. Of course, they both got 82s, but this is just measuring them, comparing them relative to the rest of the people of their class. That is the important thing about measures of positions. They're always relative to the data set. You have a different data set, could be a different measure of position. You compare my weight to the football team, hey, I am pretty thin. You compare my weight to a bunch of 3rd grade girls, hey, I'm not so thin. The comparison in measures of position is always relative to the data set you have. Okay, now we are going to look at an example from your book, number 12. The average teacher salary in a particular state is $54,166. If the standard deviation is $10,200, find the salaries corresponding to the following z-score. I am going to do A and B for you. And I am going to ask you to do C, D, and E. I'm going to ask for the answers of one of those in the next slide. So go ahead and pause this after I do A and B. Do B, C, and D yourself on some scratch paper, and then be prepared to answer that on the next slide. So, part A. Remember, it is the formula for z-score is value minus mean divided by standard deviation. So, if we have the z-score is 2, we can take my value, that's what I'm looking for, minus my mean divided by the standard deviation. Okay. 2 choices here. You gotta love that. 1, you can just plug this into your calculator, hit F2, solve in your home screen, type it in like this, 2 equals parentheses x minus 54166 close parentheses divided by 10,200 comma x close parentheses, and it will solve it for you. That's a choice. Or, because this is basic algebra, you can just do it yourself. That is 20,400 is equal to x minus 54,166. Add 54,166 to both sides. And you will find that a teacher who is 2 standard deviations above the mean is making $74,566. Okay. So that is the answer for part A. Now I will do part B for you. All right, here's B. We have got z-score equals value minus sample mean divided by sample standard deviation. We are looking for a z-score of -1. So -1 equals value we don't know minus our mean given in the problem divided by the standard deviation. All right, so we'll just solve this. Multiply both sides by 10,200 equals x minus 54,100. Add, this amount to both sides. So I'm going to add 54,166. And my answer is 43,966. Now, I want you to notice something. This is a negative z-score. Does not mean I have a negative answer. Could mean it, but it doesn't. What it means is negative z-scores are below the mean. So if you have some sort of distribution like this, here's the mean right here. That's your average. The z-scores that are positive are going to be here. The z-scores that are negative are going to be here. Negative z-scores mean that you are below the mean. You might want to write that down for yourself. All right, negative z-scores mean that you are below the mean. That's a lot of means. It has a lot of meaning. Lots of means in the meaning. All right, so I asked you to do C. I asked you to do C, D, and E yourself. So let's get that worked on. So pause the slide and find out when you are at 0. Okay, you don't even really need to do any work on that one. Think about it. You're 0 standard deviations away from the mean. You got to be sitting right at the mean. Try out the math. It works. Do this one and this one. And I'm going to ask for one of these answers when you're done. So make sure you have C, D, and E completed on scratch paper. Go ahead and pause the video now so you have time to do that. All right, so let's just recap that quick. You have a z-score, also known as a standard score. If it is positive, you are above the mean. So positive means the value is above the mean, so plus mean. And if it is negative, that means you are below the mean. So you are down here if it is negative. So that's important to know. And it's also important to know the formulas. If you have a sample z-score, then z is equal to the value minus the mean over the sample standard deviation. If you are working with populations, then z is equal to the sample minus the mean over the population standard deviation. Remember that we use different symbols for population and sample. And remember that sample and population standard deviation are actually different formulas. So it's important to keep that in mind. Right, moving on to our next thing, which is percentiles. Moving on to our next measure of position, which is percentiles. So z-scores measure position based on the standard deviation and the mean. Percentile is a measure of position that's just based on where it falls into the set relative to everything else. So percentile means breaking your set into 100 equal pieces. Percent. Cent equals 100. A penny is 1/100th of a dollar. It's 1 cent, 1/100th of a dollar. A century is 100 years. Cent per cent is per 100th. So it's 1/100th of what's going on. Percentiles are used all the time. When you get your ACT and SAT, they say you're in the 92nd percentile. That means if someone says you're in the 92nd percentile, that means that you did better, you scored better than 92% of all the people that took the test. So you are in the 92nd percentile. Oftentimes when kids go to the doctor shows them a chart that looks like this. And you will notice that on this chart, they are reading percents. They are looking at what percent a student falls in based on their age and their weight. So, for example, so this is for girls' weights. Suppose that when I was 13 years old, I weighed 95 pounds. What percentile would I be in? Well, they would go here and look at 13, and I weighed 95 pounds. So my weight would be 95. 95 is right here. And there's my 13-year-old self. And that would be on the 25th percentile. So they would make these little ogives, essentially. So they look at weight and age, and they would create this little multiple ogive. They would read it. Okay, well, 95%. This is the 20th percentile curve. If I was 95 pounds at 13, I would be in the 25th percentile. In order for me to be in the 95th percentile at the age of 13, I would need to be 95th percentile. I would need to be 160 pounds. So that would give us the 95th percentile. That means I would be bigger than 95% of the people at that age group. So you can kind of see this is a real thing. So you could check out and see what percentile you're in. This is what they use at the pediatricians, and this is how they track people. Newsflash for everyone: doesn't make sense to worry about what percentile you're in, because somebody has to be in the 90th percentile. And someone has to be in the 10th percentile. That's how these work. You can't have a distribution where everybody's over the 50th percentile. It doesn't make any sense. Somebody has to be in the 10th percentile, and that somebody else has to be in the 90th percentile. That's how percentiles work. So if you ever hear somebody say something like, well, my goal is to get everybody in the 80th percentile or above, that doesn't make any sense. Everybody can't be in the 80th percentile, not if you're measuring them relative to the group that you have. So just so you know, somebody's got to be in the 20th, somebody has to be in the 80th. That's how these guys work. So how do we calculate them? Let's take a look at a couple examples and then look at the formula. So calculating a percentile is really rather easy. Suppose you just take the number of values below the value you're looking for, because you don't know how many people are below you. You add a 0.5, and that's to step you off the value. That's so you can step off the value that you're at. And then you divide by the total number of values, and then multiply it by 100 so that you have a percentage, and that's the percentile. This part of the formula makes it a percent, because it's 1/100th, so yeah, that's the percent. So let's take a look at a quick example. Okay, so our teacher gives 10-point test to 10 students. Scores are shown on here. Find the percentile rate for the number 12. Right, our first step is we have to order these. Just like any ranking, when you find median, which is the 50th percentile, right? Same thing. So I have to order them first. 2, 3, 5, 6, 8, 10, 12, 15, 18, 20. That's our 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And we are looking for 12. And we would count how many are below that. So we have 1, 2, 3, 4, 5, 6 below. 6 plus 0.5 divided by 10 is 0.65 times 100 gives us 65%. So the person who scored 12 is in the 65th percentile. Okay, now using the same data, I would like you to find what percentile did somebody who scored a 6 on the exam get. What percentile did somebody who scored a 6 on the exam get? Pause it here, because I'm going to ask you to put that answer in on the next slide. So don't just let it continue, because if you do, you won't be able to see the data. Again, pause here and answer the following question. What percentile did somebody get, did somebody who earned a 6 in this example get? Now we're going to look at the question a different way. Instead of saying somebody scored X, what percentile they're in, we're going to say, what score would I need to get to be in the 80th percentile? So let's take a look at that exact same data we just looked at. Now I'm coming into this class and I say, boy, I really want to score in the 80th percentile. What type of score relative to this class do I need to get to be in the 80th percentile? I am going to put some little instructions here on the screen. You'll see here the instructions are 3 steps. And step 3 could be either step A or step B. Remember when we took the median, which was the 50th percentile? I said, hey, what number is in the 50th percentile? It depended on whether it was even or odd, if there was even number set or an odd number set. Step 3 takes into account whether it is even or odd. So I want to find the 80th percentile. So here's how I'm going to do it. I'm going to arrange the numbers in order again. That's the first important step. So I got them all ordered here. That's great. And now, next thing says substitute into the formula. So let's count. C is what I'm looking for. N is the total number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. P is the percent I'm looking for, the 80th. Since this is a percent, I'm going to divide by 100. So this is going to be 8. Right? So if C is not a whole number, then we round up to the next whole number. Well, that's not a problem for us. C is a whole number. So you are going to use the value halfway between the 8th and the 9th. So I am going to count up 1, 2, 3, 4, 5, 6, 7, 8, and the 9th. The value halfway between these, I'm going to average this. 15 plus 18 divided by 2. Right? So if I add those together, I get 33 divided by 2, which is 16 and a half. Don't round. So if I want to be in the 80th percentile, I need to get a score of 16 and a half on this test. It is generally wise to get in the habit of calculating your medians this way. I'm going to do it the old way and the new way. I'm going to do it the old way in a beautiful purple color right down here. So the old way goes like this. First thing I do is reorder my set. 2, 3, 5, 6, 8, 10, 12, 15, 18, 20. Should be 10. 3, 4, 5. Excellent. 10. Because it's 10, it's an even number. I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Halfway between 8 and 10. 18 divided by 2 is 9. Median is 9. That's the 50th percentile. Right? I'm going to do it my new way in a beautiful green color. New way. It looks like this. First, so we order the set again. And now it says we want the 50th percentile, so we have 10 numbers. So C equals 10, the numbers of data points we have, times 50 over 100. That equals 5. Notice 5 is a whole number, so we go halfway between our 5th and 6th. So 1, 2, 3, 4, 5. There's 6. Halfway between 8 and 9 is 10. Or 8 and 10 is 9. You'll see you get the same answer each way for the median. So this is best practice to do it this way. It sometimes can seem a little longer, but it's great when you have a really huge set and you're trying to figure out the median yourself. It works out really well that way. Let's do one more example. Again, finding what percentile, what data point is in a specific percentile. Using the same exact set, let's look for the 25th percentile. 25th percentile. So, remember our little formula, C equals NP over 100. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 still in this set. So 10 times 25 over 100 is 2.5. Now, we're using a different step. This is not a whole number. This is a partial number. So we don't need to average the two together. All we have to do is go round up to the next whole number, which is 3, and take the third thing in the set. 5 is in the 25th percentile. Right? So that is the 25th percentile is 5. What if I want 75th percentile? Let's take a look at that one. So we'd say C equals NP over 100. 10 things in our set still. Now 75 percentile over 100. 7.5 is the number. 7.5 is not a whole number, so I round up to the 8th item in my set. 15. 15 is the 75th percentile in the set. Now, it is not a coincidence that I use 25 and 75%. These are called the quartiles. All right, if you're like me, when you hear the word quartiles, you immediately think of a quarter. And I'm sure everybody wants to be like me. Woo! All right, so quartiles, quarter, means you're quartering the set. Percentiles, 100. Took it into groups of 100 little groups. This one, quartiles, you are going to look at this as if they are quarters of the set. So quartiles end up being pretty important, important enough for us to give them some notation. Q1 is the first quartile. How much money do you have when you have 1 quarter? You have 25 cents. This is the 25th percentile. Q2 has another name, 50th percentile, and 2 quarters is 50 cents. This is also known as the median. Q3 is, you guessed it, 75th percentile, because 3 quarters gives you 75 cents. So quartiles look like that. And when you calculate the quartiles, you calculate the same when you do any percentage, but they are given these special numbers. So if I had a set that looked like this, 1, 1, 7, 8, 12, or 10, 12, 18, 18, 19. That's my set. And I wanted to find the quartiles. Well, quartile 1. First of all, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 items in my set. So I would take 9 times 25 divided by 100. 9 times 25 divided by 100. So that's 2.25. That is not a whole number, that is a partial number. So I am going to round up to my next whole number, which is 3. So Q1 is equal to 7. Now let's take a look at Q2. 9 things in my set, 50th percentile, over 100. All right, 4.5 is not a whole number. round up to the next whole number, and that gives me 10. Q2, my median, is equal to 10. And finally, we'll do Q3. So when you're doing Q3, you get 9 times 75 over 100 equals 6.75. That's not a whole number. You're going to round up to 7. 1, 2, 3, 4, 5, 6, 7, 18 is my Q3. So we have some great news, some good news about quartiles. You can do it on your TI-89. Remember that our steps would be to go to our apps and then Stats List Editor. Step 2 is to enter your data. Step 3 is to choose F4, one of our stats. Step 4 is to put where it says list, you type in list 1 or whatever list you put your statistics. And where it says frequency, you type in the number 1 because each thing happened once. And then you should end up with a screen just like with our mean, median, and mode. Well, no mode. Our mean and median. You get a screen that looks like this. And you can see right here is our Q1. Remember, median is Q2, and there's Q3. So this is from a different data set, but you can see Q1, Q3. You just scroll down from where your mean is at the top to your quartiles. So that is good news. Okay, our next topic is deciles. And you guessed it, decade, deciles. They are breaking your group into 10 parts, into tenths. All right, into tenths. So, this would be finding decile 1 is the 10th percent. And decile 2 is the 20th percent. And 3 is the 30th percent. And 4 is the 40th percent, all the way up to the 90 percentile. You don't really talk about the 100th percentile. That would be saying that 100 people are below you, which doesn't really make sense. The 100th, to have 100% of all people being below you. Oftentimes I'll talk about like the 99.9 percentile. They kind of maybe corrupt the meaning a little bit. Sometimes they'll be like, oh, your kid is in the 104th percentile. And that just means they're off the curve. And that can happen, you know, that they're just that much bigger than everybody else. But statistically, we really don't talk about anything above the 99th percentile or the 99.99 percentile, whatever. We don't really talk about something being in the 100th percentile. It doesn't really make sense. The way that we define percentile is 100% of the people being below you. How is that possible? How can everybody be below you? Because you have to kind of count yourself in that. So we don't really talk about that statistically. So we calculate these the same exact way. So let's just pretend we have this set 2, 4, 6, 8, 12, 15. And I want to find the 10th percentile. So 10th percentile, D10. All right. So D10, which is D1, the first 10th percentile. Remember that I have 1, 2, 3, 4, 5, 6, 7 things here. Times 10 divided by 100. And so that would be 0.7. 0.7 is not a whole number. So I round up to my first whole number, which is 1. And in this set, 2, D2 would be D1 would be 2. It's interesting when your set is small like this. Let's take a look at D2. All right, so we have 7 numbers looking for the 20th percentile over 100. would be 1.4, round up to 2. So our 2 would be there. You're going to get to a point where you end up with the same number. Like, there aren't 10 numbers here, right? So there'll be a point where 7 times 3, for example, .1, which is round up to the third whole number. D4, 7 times 40, is 2.8, round up to the third number. So in this case, 6 represents both the 30th and the 40th percentile. And that's what happens when your sets are really small. You only have 7 numbers. You can't assign one number to each of these, 9 spots. You only have 7 numbers. So that's an important thing to keep in mind. So that, my friends, is how you calculate deciles. Same exact way as we calculate quartiles. Same exact way as we calculate percentiles. So, yay for consistency. Okay, we are in the final slide. The final countdown. All right, quick summary. What I really just want to do in this slide is wrap up what the notations are for each of the things that we talked about today. So we have our z-score. Remember that important formula was z equals the value minus the mean over the standard deviation. Okay, we are going to end up talking about that a ton in the future, so keep that one in mind. We have our percentile, which was just p sub whatever percent you wanted. So, maybe we wanted the 75th percentile, we go p75. 23rd, p23. All right, and then our decile, d1 was 10%, 2, 20%, so on. And then q1 was our first quarter, that's 25 percentile. So notice that p50 is equal to d5 is equal to q2 is equal to our median. These are all ways of saying the 50th percentile. And so these are all of our different symbols. Z, P, D, and Q. So I hope you guys have a great video. You do have some Canvas homework to do. So I look forward to seeing it, and also have a safe and relaxing weekend.